Hi, today you are going to take a look at this controller assembly. This thing was installed in a Boeing 747. I didn't find any information regarding this unit. We can see that we have a pressure port here. I think that we have here a cabin pressure controller. This thing was manufactured by Hamilton Standard. We have here a very nice circuit board. On the solder side, we have several passive parts. And we can see also here a serious budge. So actually a resistor array was added here, probably pull up or pull down. And we can see here the power supply. And here we have the pulse width modulation controller, UC1526. So here we can notice a pressure sensor. It is probably a bridge. It is connected to this circuit here. We have two quad op amps, an LT1014. This is the precision op amp. There is another one just here. And here there is a part from Linear Technology. The reference is obscure. It's a military marking probably. So this should be a voltage reference. And we have several accurate resistors. All parts have military specifications. We can see, for example, this diode. The reference starts by Jan TX. We can see also this aluminum plate, which permits heat dissipation. We have two EEPROMs here for the code. We have probably a 16-bit bus. Here we should have two static memories. And here it seems that we have a budge also, this resistor. Here we have a microprocessor or microcontroller from Intel. It's an MG8097. And here there is another part, which is probably an ASIC. The most interesting part is probably this sensor. It seems that we have two pressure sensors, this one and this one here. You can see this cylinder stuff. It is maybe a resonating cylinder sensor. There is the first module here. Now this module was manufactured by Nord Micro. It seems to be a German company. And this circuit board is linked to the second one. It uses this ribbon cable here. And there is a larger hybrid circuit on the second board here. And the sensor communicates with the main board here using a lot of wires. It can be maybe interesting to study this sensor. The first thing to do is to try to supply this unit and to take a look at the signals. I have connected the pressure input here to this vacuum pump. Currently the frequency is 7.68 kHz approximately. You can see that the frequency decreases when the pressure decreases. The pressure is 0.4 bar approximately. That is to say minus 0.6 bar below ambient pressure. At 0.6 bar, frequency is 7.06 kHz. Okay, so we have here a very nice hybrid circuit. We have here an array of transistors. Pin 1 is here. We have a first collector, base, emitter of the first transistor, and we can see that this emitter is connected to the emitter of the second transistor here. Pin 4 is the base of the second transistor, collector. Here you have the base of the third transistor, emitter, collector, base, emitter, collector, base, emitter, collector. We can see that this transistor is not used. The interesting thing is that we have these two emitters connected together. One possible part is a CA3086. We can see this part. It corresponds exactly to this die. You can see these two emitters connected together, pin 3 here. Pin 2 here corresponds to the base of the first transistor. Pin 4 is here. Pin 6, the base of Q3. 9, which is the base of Q4. 10, 11, 12, base of Q5. And 14 here, which is the collector of Q5. We can see here another die. Most of the pins are connected to ground. This line here is connected to a resistor. This one here connected to the plus 5 volts, which is here. And this line here is connected to this pin, which is the frequency output actually. So this is a square wave. So therefore it seems that we have an open collector here. It is not complicated to imagine that we have here a comparator with 14 pins. One common part is an LM139. On that line we have the plus 15 volts power supply. So let's see if this thing can be compatible with an LM139. Now this is the pin out of an LM139. Power supply is this line, which is normally pin 3. Pin number 1 and 2 are connected to ground. So this is these two outputs, which are not used. Pin 14 is here, and pin 13 is this one. It seems that we have here the output number 4. This is the ground. And here we have the non-inverting input, pin 11, and here pin 10. Therefore only one comparator is used, which is comparator number 4 here. The other pins are connected to ground. We have here another die. We can see the symmetry of this die. We have 4 identical circuits inside. It is not complicated to imagine that we have a quad op-amp here. This line corresponds to the minus 15 volts power supply, which is connected to the substrate of this die. And here we have the plus 15 volts power supply. So this corresponds to a classic pinout of a quad op-amp. Output, inverting input, non-inverting input, positive power supply, non-inverting input, inverting input, output, and the same on the other side. I don't know what is the exact reference of this part, maybe an LM124 or something like that. We have here a bipolar NPN transistor. The emitter is in the center here, base is here, and the collector is connected to this line here. This die corresponds to a diode. Anode is in the center, the cathode here. We have 3 of them on that image. We can see also several resistors. The last die is this one. This die is used for the temperature measurement. It is connected to the temperature sensor, which is a diode or more probably a transistor with collector and base connected together. And at the output there is an open collector which is connected to a second pull-up. And at the output there is a square wave. I didn't do any test, but I think that the duty cycle depends on the temperature. This part seems to be a pulse width modulation controller, but I didn't find anything compatible with the pinout of this part. We have here the complete schematic diagram of this module. The sensor itself is here. We have a cylinder here. The rigidity of the cylinder depends on the pressure. We have here 2 pairs of coils. This one is the excitation coil, and we have a pair of pickup coils here. Only one coil is shown. In between there is an amplifier in order to have the oscillation. And we have here the temperature sensor, which is probably a transistor. The resonance frequency depends, of course, on the temperature, so you need to have a compensation, which is done by firmware. This part permits to convert the junction voltage here into a frequency or probably a duty cycle. I have measured the frequency of 4.17 kHz, so I think that the duty cycle of this signal depends on the temperature, that is to say on the voltage, which is here approximately 0.7 volt. The amplifier is here. There are three stages. The first stage uses the CA3086, which is an array of transistors, so there is here a differential amplifier. The gain of this amplifier depends on the bias current here, and the bias current depends on the voltage which is present at the output of this integrator. Regulation of the amplitude is required in order to avoid the saturation at this output here. So we need to have a very clean sine signal. This is why we have a control of the gain. Sometimes a JFET transistor is used for the regulation of the amplitude. The differential output here is fed to the second amplifier, and there is the third amplifier here, which is connected to the excitation coils here. And the return line is here. There is a current sense resistor. Here we have the regulation of the current flowing through the excitation coil. The current is sensed using these two resistors here. This circuit permits to have a single wave rectifying even for very low voltage here, because this diode is inside the loop. Here we have a positive voltage. So this positive voltage creates a positive current flowing through this resistor here, and there is another current here which is negative, and the difference of these two currents is fed to this integrator, and the integrator permits to change the gain. So when this thing is stabilized, we have the same current flowing through this resistor and this one. The last circuit is this one. At this output there is a bipolar signal. This diode permits to remove the negative side of this voltage, and at the output there is a square wave, which is the output of that system. That's all for today. Thank you for watching, and see you next time for another video. Bye bye.